12.2, congruent polygons, identifying and using corresponding parts. So first of all, a corresponding part is parts of two objects in the same position after a rigid motion. So if I were to take triangle ABC and reflect it, rotate it, translate it, and it becomes triangle DEF, the parts that are in the same relative position are a corresponding part. So for example, if you kind of look at this guy, he looks like he's kind of been reflected over point A. So there might be a line somewhere here where this guy was reflected over, and then he's kind of like shifted up. So angle B would be a corresponding part to angle E. Angle A would be a corresponding part to angle D. And then the sides work the same way. So side AC is a corresponding part with side DF. Now, if you have congruent figures, corresponding angles are congruent, meaning they're the exact same measure. So looking at my picture, I could say that angle B is congruent or the same measure to angle E. I could also say that angle C is congruent to angle F, and I could say that angle A is congruent to angle D. Then we also have corresponding sides, and corresponding sides are also congruent, meaning they're the same length because these triangles are the same figure except one has been moved to a different location. So I could say side AB is congruent to side DE. I could say side BC is congruent to side EF. And then lastly, we could say side CA is congruent to side FD. Example 1, using properties of congruent figures. So it tells us that in the diagram, quadrilateral ABGH is congruent to quadrilateral CDEF, which means somehow we took ABGH, we reflected it, rotated it, we did something, and it became figure CDEF. Now, if you look really closely, we've got a 90, we've got a 90. It looks to me like this guy was maybe just like turned into this guy. So angle A could be mapped onto angle C. Angle B could be mapped onto angle D, which is then going to tell us something very specific about F and E and H and G. So part A says, identify all pairs of congruent corresponding parts. So I know that angle A is congruent to angle C. There's two ways I know that. First of all, if I look at this thing rotating, that's where it's going to land. So angle A is going to line up with angle C. The other way I know that is by how this is listed. Do you notice that A and C are in the same position of the lettering? They're both first. So if I keep going, B is going to rotate down to D. So I know angle B is congruent to angle D. I can also look and say, okay, well, this guy's second and this guy's second, so I know that they're going to be congruent or the same. If we keep going, that means that G is going to be congruent to E. And then last but not least, I know that H is going to be congruent to F. Now we have to go and we have to look at the sides. So if I go look at the sides, we can do the same thing. If I rotate this and I'm looking from A to B, I know that from A to B is going to be congruent from C to D. The other way to tell is by looking, okay, AB CD. They're both the first two letters. So when we name congruent figures, the order in which you put the letters is very, very important. Then I'm going to move on to BG, which is going to be congruent to DE. And again, BG is the second two letters, DE is the second two letters. Then I'm going to go to HG is congruent to FE. And then AH, excuse me, AH is congruent to FC. Part B, find the value of x. Now, if we look at where x is sitting, it's sitting in 4x plus 5. 4x plus 5 is angle H. Over here, I know that angle H is congruent to angle F, and angle F is 105 degrees. So now I can say that 4x plus 5 is equal to 105 degrees because corresponding angles are congruent. From here, we're going to subtract 5. 4x equals 100. Then we're going to divide by 4. So we know that x equals 20.